Testing? Okay. Hi. Good time of day. I'm late again, as usual. I was supposed to have started, well, not just 10 minutes ago, but also like an hour ago. But it's fine. I'm here. There is some news that surprised me yesterday. After the live, I guess some people watched it, and my subscriber count grew a lot more than normal, and I'm scared to say that I currently, and I'm saying on YouTube, not on Twitch, by the way, because let me show you. Okay, I'm scared to say that I have 100. I mean, I said 100. I have 1,000 subscribers now. Like, what? That's a lot of people. So that scared me, sort of. And another reason I'm scared is like people can unsubscribe. I don't mind whatever, but that happened. So yeah, surprised and scared in a good way. Okay. So today is supposed to be the last and final part of this course that I've been taking for God knows how long. I mean, I can check, but it's been a while. Introduction to Machine Learning for Coders, which is taught by Jeremy Howard. He's a cool teacher, I think at University of San Francisco. I don't know if it's still there or not because this is from 2018, but yes. And it is 12 lessons. It's supposed to be one lesson per week. And we are in lesson 12. I watched this part yesterday, and this part is for today. So it's mostly a lecture about ethical issues in, I guess, machine learning. So let's see.
Bit.
Oh, I forgot to tell my computer to bring the sound into my ear, if that's possible.
We started
Okay.
off.
And I'm gonna check if I'm louder or if, oh yeah, he's pretty loud. Okay, I'm gonna lower the volume here as well, just a bit. I don't know if it makes any difference if I lower it manually. Let's see.
Early in this course talking
It's pretty loud. I'm gonna just make it lower on OBS because I think that, so, because my voice is pretty low, so let's try.
about how actually a lot
I
of
think,
machine learning is
yeah.
kind of misplaced. People focus on predictive accuracy, like
Also, I really like my wings. They're cute. I like wings. Okay.
Amazon has a collaborative filtering algorithm for recommending books, and they end up recommending the book which it thinks you're most likely to rate highly. And so what they end up doing is probably recommending a book that you already have or that you already know about and would have bought anyway, right? Which isn't very valuable. What they should instead have done is to figure out like which book can I recommend that would cause you to change your behavior, right? And so that way we actually maximize our lift in sales due to recommendations. And so this idea of like the difference between optimizing, influencing your actions versus just kind of improving predictive accuracy. Improving predictive accuracy is a really important distinction, which is like very rarely discussed in academia or industry, kind of crazily enough. It's more discussed in industry. It's particularly ignored in most of academia. Right? So it's a really important idea, which is that in the end, the goal of your model, presumably, is to influence behavior. Okay, and remember I actually mentioned a whole paper I have about this, where I introduced this thing called the drivetrain approach, where I talk about like ways to think about how to incorporate machine learning into like how do we actually influence behavior. So,
Okay.
you know, that's a starting point. But then the next question is like, okay, if we're trying to influence behavior, what kind of behavior should we be influencing and how, and what might it mean when we start influencing behavior, right? Because like nowadays, like a lot of the companies that you're going to end up working at are big ass companies, and you'll be building stuff that can influence millions of people, right?
Yes.
So what does that mean? Um, I'm not going to tell you what it means because like I don't know. All I'm going to try and do is make you aware of some of the issues, right?
Okay.
And make you believe two things about them. First, that you should care, right?
Okay.
And second, that they're big current issues, right? The main reason I want you to care is because I want you to want to be a good person and show you that
Fair.
like not thinking about these things will make you a bad person. But if you don't find that convincing, I will tell you this. Volkswagen were found to be cheating on their emissions tests. The person who was sent to jail for it was the programmer that implemented that piece of code. They did exactly what they were told to do, right? And so if you're coming in here thinking, hey, I'm just a techie, you know, I'll just do what I'm told, right? That's
wait. Admission for what? For like new people?
that's my job.
Emission, sorry, I heard admission. Okay.
Just to do what I'm told. I'm telling you, if you do that, you can be sent to jail for doing what you're told.
Wow.
Okay? So A, don't just do what you're told because you can be a bad person, and B, you can go to jail. Okay? Second thing to realize is in the heat of the moment, you're in a meeting with 20 people at work, and you're all talking about how you're going to implement, you know, this new feature, and everybody's discussing it. And there's some, you know, and everybody's like, we could do this, and here's a way of modeling it, and then we can implement it, and here's these constraints. And there's some part of you that's thinking, am I sure we should be doing this?
Yeah.
Right? That's not the right time to be thinking about that, because it's really hard to like step up then and say, excuse me, I'm not sure this is a good idea. You actually need to think about how you would handle that situation ahead of time. Right? So I want you to like think about these issues now, right? And realize that by the time you're in the middle of it, right, you might not even realize it's happening. You know, like it'll just be a meeting, like every other meeting, and a bunch of people will be talking about how to solve this technical question. Okay? And you need to be able to recognize, like, oh, this is actually something with ethical implications. So
that's a good point, because when you're in the thick of it, you are way too concerned about tiny details that you actually might lose the big picture. Yeah.
Rachel actually wrote all of these slides. I'm sorry she can't be here to present this because like she's
I should probably change my... Yeah, so that you guys can also see what's happening.
Studied this in depth, and you know she's actually been in difficult environments herself where she's kind of seen these things happening. You know, and you know, we know how hard it is, right? But let me give you a sense of like what happens, right? So engineers trying to solve engineering problems is, you know, and causing problems is not a new thing, right? So in Nazi Germany, IBM, the group known as Hollerith, right? Hollerith was the original name of IBM, and it comes from the guy who actually invented the use of punch cards for tracking the US census, the first mass wide-scale use of punch cards for data collection in the world, right? And that turned into IBM. And so at this point, this unit at least was still called Hollerith. So Hollerith sold a punch card system to Nazi Germany. And so each punch card would like code, you know, this is a Jew, 8, Gypsy, 12, general execution, 4, death by gas chamber, 6. And so here's one of these cards describing the right way to kill these various people, right? And so a Swiss judge ruled that IBM's technical assistance facilitated the tasks of the Nazis and commission of their crimes against humanity. This led to the death of something like 20 million civilians. So according to the...
Why did I not know about this? I had no idea about this side. Because like, wow.
The Jewish Virtual Library, where I got these pictures and quotes from, their view is that the destruction of the Jewish people became even less important because of the invigorating nature of IBM's technical achievement, only heightened by the fantastical profits to be made. Right? So this was a long time ago, and you know, hopefully you won't end up working at companies that facilitate genocide, right? But perhaps
this is so effing relevant right now. Don't work for companies that facilitate genocide. What a good PSA.
you will, right? Because perhaps you'll go to Facebook who are facilitating genocide right now, right? And
Uh-huh.
I know people at Facebook who are doing this and they had no idea they were doing this, right? So right now in Facebook, the Rohingya are in the middle of a genocide, a Muslim population of Myanmar. Um, uh, Babies are being grabbed out of their mother's arms and thrown into fires. People are being
Oosh.
killed, hundreds of thousands of refugees. When interviewed, the Myanmar generals doing this say, we are so grateful to Facebook for letting us know about the Rohingya fake news, the words they use, the Rohingya fake news,
Ah.
that these people are actually not human, that they're actually animals. Right? Now, Facebook did not set out to enable the genocide of the Rohingya people in Myanmar. No, instead what happened is they wanted to maximize impressions and clicks. Right? And so it turns out that for the data scientists at Facebook, their algorithms kind of learned that if you take the kinds of stuff people are interested in and feed them slightly more extreme versions of that, you're actually going to get a lot more impressions. And the project managers are saying maximize these impressions, and people are clicking, and like it creates this thing, right? And so
Right.
the 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 potential implications are extraordinary and global, right? And this is something that like is literally happening. You know, this is October 2017. It's happening now. Okay, could you pass that back there?
So I just want to clarify what was happening here. So it was the facilitation of like fake news or like inaccurate media. Is
Yeah, so what happened was, let me go into it in more detail. So what happened was in mid-2016, Facebook fired its human editors. Right? And so it was humans that decided how to order things on your homepage. Those people got
Mm-hmm.
fired and replaced with machine learning algorithms. And so the machine learning algorithms written by data scientists like um, you know, they had nice, clear metrics, and they were trying to maximize their predictive accuracy and be like, okay, we think if we put this thing higher up than this thing, we'll get more clicks. Okay. And so it turned out that these algorithms for putting things on the Facebook newsfeed had a tendency to say like, oh, human nature is that we tend to click on things which like
Angry.
stimulate our views and are therefore like more extreme versions of things we already see.
Mm-hmm.
Okay, so this is great for the kind of Facebook revenue model of maximizing engagement. It looked good on all of their KPIs. And so at the time, you know, there was some negative press about like, you know, I'm not sure that the stuff that Facebook's now putting on their trending section is actually that accurate. But from the point of view of the metrics that people were optimizing at Facebook, it looked terrific. Right? And so way back to October of 2016, people started noticing some serious problems. For example, it is illegal to target housing to people of certain races in America.
Mm-hmm.
That is illegal. And yet, a news organization discovered that Facebook was doing exactly that, right, in October 2016. Again, not because somebody in that data science team said, like, let's make sure black people can't live in nice neighborhoods, right? But
Oh,
instead, you
it's
know,
a
they
setting.
found that their automatic clustering and segmentation algorithm found there was a cluster of people who didn't like African Americans, and that if you targeted them with these kinds of ads, then they would be more likely to
I thought it's like they allow it as a setting for other people to choose, but it's automatic. Shoot.
select this kind of housing or whatever, right? But the interesting thing is that even after being told about this 3 times, Facebook still hasn't fixed it, right? And that is to say, these are not just technical issues, they're also economic issues, right? When you start saying like the thing that you get paid for, that is ads, you have to change the way that you structure those so that, you know, you either use more people that cost money, or you like are less aggressive on your algorithms to target people, you know, based on like minority group status or whatever. You know, that can impact revenues. And so the reason I mention this is you will likely at some point in your career find yourself in a conversation where you're thinking, I'm not confident that this is like morally okay. And the person
Mm.
you're talking to is thinking in their head, this is going to make us a lot of money, right? And you don't quite ever manage to have a successful conversation because you're talking about different things, you know? And so when you're talking to somebody who may be more experienced and more senior than you, and they may sound like they know what they're talking about, right? Just realize that their incentives are not necessarily going to be focused on like, how do I be a good person? You know, like they're
Right.
not thinking, how do I be a bad person? But, you know, the more time you spend in industry, in my experience, the more desensitized you kind of get to this stuff of like, okay, maybe getting promotions and making money isn't the most important thing, right? So, for example, I've got a lot of friends who are very good at computer vision, and some of them have gone on to create startups that seem like they're almost handmade to help authoritarian governments surveil their, you know, their citizens. And when I ask my friends, like, have you thought about how this could be used in that way? You know, they're generally kind of offended that I ask, you know. But I'm asking you to think about this. Like, you know, wherever you end up working, if you end up creating a startup, like, tools can be used for good or for evil, right? And so I'm not saying, like, don't create excellent object tracking and detection tools in computer vision.
Is this? Because wow, my eyes cannot even comprehend these people, and the camera's so good at it.
Because, yeah, you could go on and use that to create, like, a much better surgical intervention robot toolkit, right? I'm just saying, like, be aware of it, think about it, talk about it, you know? So here's one I find, like, fascinating, and there's this really cool thing, actually, that meetup.com did. This is from a meetup.com talk that's online. They think about this. They actually thought about this. They actually thought, you know what? If we built a collaborative filtering system, like we learned about in class, to help people decide what meetup to go to, it might notice that on the whole in San Francisco, a few more men than women tend to go to techie meetups.
Obviously.
And so it might then start to decide to recommend techie meetups to more men than women. As a result of which, more men will go to techie meetups. As a result of which, when women go to techie meetups, they'll be like, oh, this is all men. I don't really want to go to techie meetups. As a result of which, the algorithm will get new data saying that men like techie meetups better, right? And so it continues, right? And so, like, a little bit of kind of that initial push from the algorithm can create this runaway feedback loop, and you end up with, like, almost all male techie meetups, for instance, right? And so this kind of feedback loop is a kind of subtle issue that you really want to think about when you're thinking about, like, what is the behavior
It's a snake eating itself, isn't it?
that I'm changing with this algorithm that I'm building. So another example, which is kind of terrifying, is in this paper, where the authors describe how a lot of departments in the US are now using predictive policing algorithms, right? So where can we go to find somebody who's about to commit a crime? And so you know that the algorithm simply feeds back to you basically the data that you've given it, right? So if your police department has engaged in racial profiling at all in the past, then it might suggest slightly more often, maybe you should go to the black neighborhoods to check for people committing crimes, right? As a result of which, more of your police officers go to the black neighborhoods. As a result of which, they arrest more black people. As a result of which, the data says that the black neighborhoods are less safe. As a result of which, the algorithm says to policemen, maybe you should go to the black neighborhoods more often, and so forth, right? And this is not like, you know, vague possibilities of something that might happen in the future. This is like documented work from top academics who have carefully studied the data and the theory, right? This is like serious scholarly work. It's like, no, this is happening right now. And so, you know, again, like,
even I'm reading this, I mean, I'm slowly reading this book called The Alignment Problem, and you'd be surprised at how early some of these algorithms started being used. So, yeah.
I'm sure the people that started creating this predictive policing algorithm didn't think, like, how do we arrest more black people, right? You know, hopefully they were actually thinking, gosh, I'd like my children to be safer on the streets. How do I create, you know, a safer society, right? But they didn't think about this nasty runaway feedback loop. So actually this one about social network algorithms is actually an article in the New York Times recently about one of my friends, Renee DeResta, and she did something that was kind of amazing. She set up a second Facebook account, right, like a fake Facebook account, and she was very interested in the anti-vax movement at the time. So she started following a couple of anti-vaxxers and visited a couple of anti-vaxxer links. And so suddenly her newsfeed starts getting full of anti-vaxxer news, along with other stuff like chemtrails and deep state conspiracy theories and all this stuff. And so she's like, starts clicking on those, right? And the more she clicked, the more hardcore, far-out conspiracy stuff Facebook recommended. So now when Renee goes to that Facebook account, the whole thing is just full of angry, crazy, far-out conspiracy stuff. Like, that's all she sees. And so if that was your world, right, then as far as you're concerned, it's just like this continuous reminder and proof of all this stuff, right? And so again, it's like this is, to answer your question, this is the kind of runaway feedback loop that ends up telling me and my generals, you know, throughout their Facebook homepage that Rohingya animals and fake news and whatever else, right? So, it's a lot of this comes also from bias, right? And so, like, let's talk about bias specifically. So bias in image software comes from bias in data. And so most of the folks I know at Google Brain building computer vision algorithms, very few of them are people of color. And so when they're training the algorithms with, photos of their families and friends, they are training them with very few people of color. And so when FaceApp then decided we're going to try looking at lots of Instagram photos to see which ones are like, upvoted the most, without them necessarily realizing it, the answer was like, light-colored faces. So then they built a generative model to make you more hot. And so this is the actual photo, and here is the hotter version, right? So the hotter version is like more white, less nostrils, more European looking, right? And so like this did not go down well, to say the least. So like so again, I don't think anybody at FaceApp said like, let's create something that makes people look more white, right? They just trained it on a bunch of images of the people that they had around them, okay? And this has kind of, serious commercial implications as well. They had to pull this feature, right? And they had a huge amount of negative pushback, like as they should, right? Here's another example. Google Photos created this photo classifier: airplanes, skyscrapers, cars, graduation, and gorillas, right? So like think about how this looks to like most people. Like most people, they look at this, they don't know about machine learning. They say, what the fuck? Somebody at Google wrote some code to take black people and call them gorillas. Like that's what it looks like, right? Now we know that's not what happened, right? We know what happened is, the
Bad
team,
data.
of folks at Google computer vision experts who have none or few people of color working in the team, built a classifier using all the photos they had available to them. And so when the system came across, a person with dark skin, it was like, oh, I've only mainly seen that before amongst gorillas, so I'll put it in that category, right? So again, it's the bias in the data creates a bias in the software. And again, the commercial implications were very significant. Like Google really got a lot of bad PR from this, as they should. This was a photo that somebody put in their Twitter feed. They said like, look what Google Photos just decided to do. You can imagine what happened with the first international beauty contest judged by artificial intelligence.
Oh God.
Right? Basically, it turns out all the beautiful people are white. Again, right? So like you kind of see this bias in image software, thanks to bias in the data, thanks to lack of diversity in the teams building it. You see the same thing in natural language processing. Right? So here is Turkish. O is the pronoun in Turkish, which has no gender. Right? There is no he or versus she, right? No he versus she. But of course, in English, we don't really have a widely used.
My language doesn't even use gendered language as well for third person. So, I mean, the dialect I speak. So yeah, it could happen. I mean, it shouldn't because it's updated, but yeah.
Ungendered singular pronouns. So Google Translate converts it to this. Okay. Now,
Shoot.
there are
This
plenty of
part is
people who saw
annoying.
this online and said, like, literally, so what? It is correctly feeding back the usual usage in English. Like this is, I know how this is trained. This is like word-to-vec vectors. It was trained on Google News corpus, Google Books corpus. It's just telling us how things are. And like, from a point of view, that's entirely true, right? Like, the biased data to create this biased algorithm is the actual data of how people have written books and newspaper articles for decades. But does that mean that this is the product that you want to create? Does this mean this is the product you have to create? Right? Just because the particular way you've trained the model means it ends up doing this, is this actually the design you want? And can you think of potential negative implications and feedback loops this could create? Right? And if any of these things bother you, then now, lucky you have a new cool engineering problem to work on. Like, how do I create unbiased NLP solutions? And now there are some startups starting to do that and starting to make some money, right? So like, these are opportunities for you. It's like, hey, here's some stuff where people are creating screwed up societal outcomes because of their shitty models. Like, okay, well, you can go and build something better, right? So like another example of the bias in word-to-vec word vectors is restaurant reviews rank Mexican restaurants worse because the Mexican words tend to be associated with criminal words in the US press and books more often. Again, this is like a real problem that is happening right now. So, Rachel actually did some interesting analysis of just the plain word vectors, where she basically pulled them out and, looked at these analogies based on some research that had been done elsewhere. And so you can see, like, word to vec, like the vector directions show that father is to doctor, as to mother is to nurse, man is to computer programmer, as woman is to homemaker.
This is making me angry.
So, right? So, like, it's really easy to see what's in these word vectors. And, they're kind of fundamental to much of the NLP, or probably just about all of the NLP software we use today. So, like, here's a great example. So ProPublica has actually done a lot of good work in this area. Many judges now have access to sentencing guideline software. And so sentencing guideline software says to the judge, for this individual, we would recommend this kind of sentence, right? And now, of course, the judge doesn't understand machine learning. So, like, they have two choices, which is either do what it says or ignore it entirely, right? And some people fall into each category, right? And so for the ones that fall into the, like, do what it says category, here's what happens. For those that were labeled higher risk, right, the subset of those that were labeled higher risk, which actually turned out not to reoffend, right, was about a quarter of whites and about a half of African Americans, right? So, like, nearly twice as often, right, people who didn't reoffend were marked as higher risk if they were African American, and vice versa. Amongst those that were labeled lower risk, but actually did reoffend, turned out to be about half of the whites, and only 28% of the African Americans. Like, so, like, this
example and the Google Photos examples are both available in the alignment problem book. Yeah, so I've seen this before.
Data which I would like to think nobody is setting out to create something that does this, right? But when you start with biased data, right, and the data
actually, it might not be this exact version. I don't know. I don't know if it's as updated because the book isn't that new.
It says that whites and blacks smoke marijuana at about the same rate, but blacks are jailed at, I think it's something like 5 times more often than whites. Like, the nature of the justice system in America, at least at the moment, is
messed
that
up.
It's not equal, it's not fair. And therefore the data that's fed into the machine learning model is going to basically support that status quo. And then because of the negative feedback loop, it's just going to get worse and worse, right? I'll tell you something else interesting about this one, which researcher called Ed Gong has pointed out, is here are some of the questions that are being asked, right? So let's take one. Was your father ever arrested? Right? So your answer to that question is going to decide whether you're locked up and for how long. Right? Now, as a machine learning researcher, do you think that might improve the predictive accuracy of your algorithm and get you a better R-squared? It could well, right? I don't know. Maybe it does. You try it out, it's like, oh, I got a better R-squared. So does that mean you should use it? Like, well, there's another question. Like, do you think it's reasonable to lock somebody up for longer because of who their dad was?
No.
Right? And yet these are actually the examples of questions that we are asking right now to offenders and then putting into a machine learning system to decide what happens to them. Okay? So again, like, whoever designed this, presumably they were like laser focused on technical excellence, getting the maximum area under the ROC curve, and I found these great predictors that give me another 0.02, right? And I guess didn't stop to think like, well, is that a reasonable way to decide who goes to jail for longer? So, like, putting this together, you can kind of see how this can get, more and more scary. We take a company like Taser, right? And Tasers are these devices that kind of give you a big electric shock, basically. And Taser's managed to do a great job of creating strong relationships with some academic researchers who seem to say whatever they tell them to say. To the extent where now, if you look at the data, it turns out that there's a much higher there's a pretty high probability that if you get tased, that you will die. It happens, not unusually. And yet, the researchers who they've paid to look into this have consistently come back and said, oh no, it was nothing to do with the taser. The fact that they died immediately afterwards was totally unrelated. It was just a random, things happen. So this company now owns 80% of the market for body cameras. And they started buying computer vision AI companies. And they're going to try and now use these police body camera videos to anticipate criminal activity. Right? And so, like, what does that mean? right? So is that like, okay, I now have some augmented reality display saying like, tase this person because they're about to do something bad. So it's like, it's kind of like a worrying direction. And so, I'm sure nobody who's a data scientist at Taser or at the companies that they bought out is thinking like, this is the world I want to help create. But they could find themselves in, or you could find yourself in the middle of this kind of discussion where it's not explicitly about that topic, but there's part of you that says like, I wonder if this is how this could be used. Right? And I don't know exactly what the right thing to do in that situation is, because like you can ask, and of course people are going to be like, no, 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 no. So it's like, are you going to, what could you do? You could like ask for some kind of written promise. You could decide to leave. You could, start doing some research into the legality of things to say like, oh, I want to at least protect my own, legal situation. I don't know. Like, have a think about how you would respond to that.
Whistleblower.
So these are some questions that Rachel created as being things to think about, right? So if you're looking at building a data product or, using a model, like if you're building a machine learning model, it's for a reason, okay? You're trying to do something, right? So what bias may be in that data, right? Because whatever bias is in that data ends up being a bias in your predictions, potentially then biases the actions that you're influencing, potentially then biases the data that you come back, and you may create a feedback loop. If the team that built it isn't diverse, what might you be missing, right? So for example, one senior executive at Twitter called the alarm about major Russian bot problems at Twitter way back, well before the election. That was the one black person in the exec team at Twitter.
Wow.
The one. And shortly afterwards, they lost their job, right? And so, like, definitely having a more
I think the Google ethics issue hadn't happened then, because that was a whole thing.
diverse team means having a more diverse set of opinions and beliefs and ideas and things to look for and so forth. So non-diverse teams seem to make more of these bad mistakes. Can we audit the code? Is it open source? Check for the different error rates amongst different groups. Is there like a simple rule we could use instead that's like extremely interpretable and easy to communicate? And like, if something goes wrong, do we have a good way to deal with it, right? So when we've talked to people about this, and a lot of people like have come to Rachel and said like, I'm concerned about something my organization's doing. What do I do? Or I'm just concerned about my toxic workplace. What do I do? And very often, Rachel will say like, well, have you considered leaving? And they will say, oh, I don't want to lose my job.
Not easy.
Right? But actually, if you can code, you're in like 0.3% of the population. If you can code and do machine learning, you're in probably like 0.01% of the population. You are massively, massively in demand. So like realistically, obviously it's an organization does not want you to feel like you're somebody who could just leave and get another job. That's not in your interest, in their interest. But that is absolutely true, right? And so one of the things I hope you leave this course with is enough self-confidence to recognize that you have the skills, to get a job. And particularly once you've got your first job, your second job is an order of magnitude easier, right?
Yeah.
And so, this is important not just so that you feel like you actually have the ability to act ethically, but it's also important to realize, like, if you find yourself in a toxic environment, right, which is pretty damn common, unfortunately. Like, there's a lot of shitty tech cultures, environments, particularly in the Bay Area, right? If you find yourself in one of those environments, the best thing to do is to get the hell out, right? And if you don't have the self-confidence to think you can get another job, you can get trapped, right? So, it's really important. Really important to know that you are leaving this program with very in-demand skills, and particularly after you have that first job, you're now somebody with in-demand skills and a track record of being employed in that area. Okay.
Oh,
okay, great.
That's it?
So, yes.
Wow.
This is kind of just a broad question, but what are some things that you know of that people are doing to treat bias in data?
It's kind of like a bit of a controversial subject at the moment, and there are like some people are trying to use an algorithmic approach, where they're basically trying to say, how can we identify the bias and kind of like subtract it out? But like the most effective ways I know of are ones that are trying to treat it at the data level. So like start with a more diverse team, particularly a team involving, which includes people from the humanities, like sociologists, psychologists, economists, people that understand feedback loops and implications of human behavior. And they tend to be equipped with, good tools for kind of identifying and tracking these kinds of problems. And then kind of trying to incorporate the solutions into the process itself. Let's say there isn't kind of like a, some standard process I can point you to and say, here's how to solve it. If there is such a thing, we haven't found it yet. It requires a diverse team of smart people to be aware of the problems and work hard at them, is the short answer.
Right.
Can you pass that back, please?
This is just kind of a general thing, I guess, for the whole class. If you're interested in this stuff, I read a pretty cool book. Jeremy, you've probably heard of it, Weapons of Mass Destruction, by Kathy O'Neill. It covers a lot of the same stuff, just more on the topic. So
thanks for the recommendation. So Kathy's great. She's also got a TED Talk. I didn't manage to finish the book because it's so damn depressing. I was just like, no more.
I haven't read it.
But yeah, it's it's very good. All right. Well, that's it. Thank you, everybody. This has been really intense for me. Obviously this was meant to be something that I was sharing with Rachel. So I've, ended up doing one of the hardest things in my life, which is to teach 2 people's worth of course on my own, and also look after a sick wife and have a toddler, and also do a deep learning course, and also do all this with a new library that I just wrote.
Whoa.
So I'm looking forward to getting some sleep. But it's been totally worth it, because you've been amazing. Like I'm thrilled with how you've, reacted to the kind of, the opportunities I've given you, and also to the feedback that I've given you. So congratulations.
Aw. I didn't know that he had issues while doing this. Huh. That looks like a interesting video. When was this?
Hi everyone.
Hi.
So by now you have probably
1 year ago. Whoa. Huh. Okay. So let me just close this out. I mean, I'm not gonna end the stream. I just wanna note that we did it, sort of. I can say that my basic understanding has grown a lot more thanks to this course. I still have a lot more to learn, but this is an introductory course. So I am going to learn other things, obviously. But yeah, if anyone's interested in learning, I don't know if there's any newer versions. What's part 2? I know that Jeremy Howard's YouTube channel is very active. So like, where's his name? I wanna copy and paste his name. I don't wanna write it wrong because I might. Okay. So even if his courses, hey Google, search for me. Okay, fine, whatever. Even if his courses are not updated, he has new, yeah, like this one, A Hacker's Guide to Language Models, CUDA for Python programmers. Yeah. Okay. I'm still like in shock that I got to finish this. I have another like half an hour to burn, so I am going to. This is not half an hour, so I'm just gonna see what this video is, and or should I just like think? I don't know, because right now I'm between these two. This here, advanced NLP and Hugging Face NLP. I definitely need to do both somehow. So we have setup, obviously, right? We should start with setup, no? What's with why? Okay. We have 9 lessons and here there are around 20 lessons, and in a way they're not really okay. So Transformers starts here, whilst Transformers is the first lesson. I don't know. I don't know what to do. I think I could just like alternate days learning this or that. It's probably not easy, but I could. I don't know. I'm sleepy. um, so let's just see what this video is, just for fun. It's Andrei Karpathy, I think. I mean, I know him, but I'm just saying if I'm saying his name correctly. Let's see how high the sound is.
So by now you have probably heard of ChatGPT. It has taken the world and the AI community by storm. And it is a system that allows you to interact with an AI and give it text-based tasks. So for example, we can ask ChatGPT to write us a small haiku about how important it is that people understand AI, so they can use it to improve the world and make it more prosperous. So when we run this, AI knowledge brings prosperity for all to see, embrace its power. Okay, not bad. And so you could see that ChatGPT went from left to right and generated all these words sort of sequentially. Now, I asked it already the exact same prompt a little bit earlier, and it generated a slightly different outcome. AI's power to grow, ignorance holds us back, learn, prosperity waits. So pretty good in both cases and slightly different. So you can see that ChatGPT is a probabilistic system, and for any one prompt, it can give us multiple answers, sort of replying to it. Now, this is just one example of the prompt. People have come up with many, many examples, and there are entire websites that index interactions with ChatGPT. And so many of them are quite humorous. Explain HTML to me like I'm a dog. Write release notes for chess2. Write a note about Elon Musk buying a Twitter, and so on. So as an example, please write a breaking news article about a leaf falling from a tree.
Oh, wow.
In a shocking turn of events, a leaf has fallen from a tree in the local park. Witnesses report that the leaf, which was previously attached to the branch of a tree, detached itself and fell to the ground. Very dramatic. So you can see that this is a pretty remarkable system, and it is what we call a language model, because it models the sequence of words or characters or tokens more generally, and it knows how sort of words follow each other in English language. And so from its perspective, what it is doing is it is completing the sequence. So I give it the start of a sequence, and it completes the sequence with the outcome. And so it's a language model in that sense. Now, I would like to focus on the under the hood components of what makes ChatGPT work. So what is the neural network under the hood that models the sequence of these words? And that comes from this paper called Attention is All You Need in 2017, a landmark paper in AI that produced and proposed the transformer architecture. So GPT is short for generatively pre-trained transformer. So transformer is the neural net that actually does all the heavy lifting under the hood. It comes from this paper in 2017. Now, if you read this paper, reads like a pretty random machine translation paper, and that's because I think the authors didn't fully anticipate the impact that the transformer would have on the field. And this architecture that they produced in the context of machine translation, in their case, actually ended up taking over the rest of AI in the next 5 years after. And so this architecture, with minor changes, was copy-pasted into a huge amount of applications in AI in more recent years. And that includes at the core of ChatGPT. Now, we are not going to, what I'd like to do now is I'd like to build out something like ChatGPT. But we're not going to be able to, of course, reproduce ChatGPT. This is a very serious production-grade system. It is trained on a good chunk of internet, and then there's a lot of pre-training and fine-tuning stages to it, and so it's very complicated. What I'd like to focus on is just to train a transformer-based language model.
Okay.
And in our case, it's going to be a character-level language model. I still think that is very educational with respect to how these systems work. So I don't want to train on a chunk of internet. We need a smaller data set. In this case, I propose that we work with my favorite toy data set. It's called Tiny Shakespeare. And what it is basically, it's a concatenation of all of the works of Shakespeare, in my understanding. And so this is all of Shakespeare in a single file. This file is about 1 megabyte, and it's just all of Shakespeare.
Wow.
And what we are going to do now is we're going to basically model how these characters follow
All of Shakespeare is 1 megabyte. Think about that.
each other. So for example, given a chunk of these characters, like this, given some context of characters in the past, the transformer neural network will look at the characters that I've highlighted, and it's going to predict that G is likely to come next in the sequence. And it's going to do that because we're going to train that transformer on Shakespeare. And it's just going to try to produce character sequences that look like this. And in that process, it's going to model all the patterns inside this data. So once we've trained the system, I'd just like to give you a preview, we can generate infinite Shakespeare. And of course, it's a fake thing that looks kind of like Shakespeare.
Infinite Shakespeare?
Apologies for, there's some jank that I'm not able to resolve in here, but you can see how this is going character by character, and it's kind of like predicting Shakespeare-like language. So, verily, my lord, the sights have left thee again, the king, coming with my curses with precious pale. And then Tranio says something else, etc. And this is just coming out of the transformer in a very similar manner as it would come out in ChatGPT. In our case, character by character. In ChatGPT,
Word by
it's
word?
coming out on the token by token level, and tokens are these sort of like little subword pieces. So they're not word level, they're kind of like word chunk level.
Okay.
And now, I've already written this entire code to train these transformers, and it is in a GitHub repository that you can find, and it's called NanoGPT. So NanoGPT is a repository that you can find on my GitHub, and it's a repository for training transformers on any given text. And what I think is interesting about it, because there's many ways to train transformers, but this is a very simple implementation. So it's just 2 files of 300 lines of code each. One file defines the GPT model, the transformer, and one file trains it on some given text dataset. And here I'm showing that if you train it on an open web text dataset, which is a fairly large dataset of web pages, then I reproduce the performance of GPT-2. So GPT-2 is an early version of OpenAI's GPT from 2017, if I recall correctly. And I've only so far reproduced the smallest 124 million parameter model. But basically, this is just proving that the code base is correctly arranged, and I'm able to load the neural network weights that OpenAI has released later. So you can take a look at the finished code here in NanoGPT. But what I would like to do in this lecture is I would like to basically write this repository from scratch. So we're going to begin with an empty
that's
file,
sweet.
and we're going to define a transformer piece by piece. We're going to train it on the tiny.
I actually like it when people write the code with you and not explain what's already written, even though both is, fine. But I enjoyed more because I can focus more.
Shakespeare dataset, and we'll see how we can then generate infinite Shakespeare. And of course, this can copy-paste to any arbitrary text dataset that you like. But my goal really here is to just make you understand and appreciate how under the hood ChatGPT works. And really all that's required is a proficiency in Python and some basic understanding of calculus and statistics. And it would help if you also see my previous videos on the same YouTube channel, in particular my Make More series, where I define smaller and simpler neural network language models, so multi-level perceptrons and so on. It really introduces the language modeling framework, and then here in this video we're going to focus on the transformer neural network itself.
Okay.
Okay, so I created a new Google Colab Jupyter notebook here, and this will allow me to later easily share this code that we're going to develop together with you, so you can follow along. So this will be in the video description later. Now, here I've just done some preliminaries. I downloaded the dataset, the tiny Shakespeare dataset, at this URL, and you can see that it's about a 1 megabyte file. Then here I open the input.txt file and just read in all the text as a string, and we see that we are working with 1 million characters roughly.
Okay.
And the first 1,000 characters, if we just print them out, are basically what you would expect. This is the first 1,000 characters of the tiny Shakespeare dataset, roughly up to here. So far so good. Next, we're going to take this text, and the text is a sequence of characters in Python. So when I call the set constructor on it, I'm just going to get the set of all the characters that occur in this text. And then I call list on that to create a list of those characters instead of just a set, so that I have an ordering, an arbitrary ordering. And then I sort that. So basically we get just
Every character or ABC? Okay, it is set meaning unique. Ah, okay, so this is ABC.
all the characters that occur in the entire dataset, and they're sorted. Now the number of them is going to be our vocabulary size. These are possible elements of our sequences. And we see that when I print here the characters, there's 65 of them in total. There's a space character, and then all kinds of special characters, and then capitals and lowercase letters. So that's our vocabulary, and that's the sort of like possible characters that the model can see or emit. Okay, so next we would like to develop some strategy to tokenize the input text. Now, when people say
It's
tokenize,
single
we convert
character.
the raw text as a string to some
His goal is single character, right?
Sequence of integers according to some vocabulary of possible elements.
Oh.
So as an example, here we are going to be building a character level language model. So we're simply going to be translating individual characters into integers. So let me show you a chunk of code that sort of does that for us. So we're building both the encoder and the decoder. And let me just talk through what's happening here. When we encode an arbitrary text, like hi there, we're going to receive a list of integers that represents that string. So for example, 46, 47, etc. And then we also have the reverse mapping. So we can take this list and decode it to get back the exact same string. So it's really just like a translation to integers and back for arbitrary string. And for us, it is done on a character level. Now the way this was achieved is we just iterate over all the characters here and create a lookup table from the character to the integer and vice versa. And then to encode some string, we simply translate all the characters individually, and to decode it back, we use the reverse mapping and concatenate all of it. Now this is only one of many possible encodings, or many possible sort of tokenizers, and it's a very simple one. But there's many other schemas that people have come up with in practice. So for example, Google uses sentence piece. So sentence piece will also encode text into integers, but in a different schema, and using different vocabulary. And sentence piece is a subword sort of tokenizer. And what that means is that you're not encoding entire words, but you're not also encoding individual characters. It's a subword unit level. And that's usually what's adopted in practice. For example, also OpenAI has this library called TickToken that uses a byte pair encoding tokenizer. And that's what GPT uses. And you can also just encode words into, like hello world, into a list of integers. So as an example, I'm using the TickToken library here. I'm getting the encoding for GPT-2, or that was used for GPT-2. Instead of just having 65 possible characters, or tokens, they have 50,000 tokens. And so when they encode the exact same string, hi there, we only get a list of 3 integers. But those integers are not between 0 and 64. They are between 0 and 50,000 to 56. So basically you can trade off the codebook size and the sequence lengths. So you can have very long sequences of integers with very small vocabularies, or you can have short sequences of integers with very large vocabularies. And so typically people use in practice these subword encodings, but I'd like to keep our tokenizer very simple. So we're using character level tokenizer.
Yeah.
And that means that we have very small codebooks. We have very simple encode and decode functions, but we do get very long sequences as a result. But that's the level at which we're going to stick with this lecture because it's the simplest thing. Okay, so now that we have an encoder and a decoder, effectively tokenizer, we can tokenize the entire training set of Shakespeare. So here's a chunk of code that does that. And I'm going to start to use the PyTorch library, and specifically the torch.tensor from the PyTorch library. So we're going to take all of the text in Tiny Shakespeare, encode it, and then wrap it into a torch.tensor to get the data tensor. So here's what the data tensor looks like when I look at just the first 1,000 characters, or the 1,000 elements of it. So you see that we have a massive sequence of integers. And this sequence of integers here is basically an identical translation of the first 1,000 characters here. So I believe, for example, that 0 is a new line character, and maybe 1 is a space. Not 100% sure. But from now on,
1 is space, yeah, I noticed.
It's just stretched out as a single very large sequence of integers. Let me do one more thing before we move on here. I'd like to separate out our dataset into a train and a validation split.
Right.
So in particular, we're going to take the first 90% of the dataset and consider that to be the training data for the transformer, and we're going to withhold the last 10% at the end of it to be the validation data. And this will help us understand to what extent our model is overfitting. So we're going to basically hide and keep the validation data on the side, because we don't want just a perfect memorization of this exact Shakespeare. We want a neural network that sort of creates Shakespeare-like text. And so it should be fairly likely for it to produce the actual, like, stowed away, true Shakespeare text. And so we're going to use this to get a sense of the overfitting. Okay, so now we would like to start plugging these text sequences or integer sequences into the transformer so that it can train and learn those patterns. Now, the important thing to realize is we're never going to actually feed entire text into a transformer all at once. That would be computationally very expensive and prohibitive. So when we actually train a transformer on a lot of these datasets, we only work with chunks of the dataset. And when we train the transformer, we basically sample random little chunks out of the training set and train on just chunks at a time. And these chunks have basically some kind of a length and some maximum length. Now, the maximum length typically, at least in the code I usually write, is called block size. You can find it under different names like context length or something like that. Let's start with the block size of just 8. And let me look at the first train data characters. The first block size plus 1 characters. I'll explain why plus 1 in a second. So this is the first 9 characters in the sequence, in the training set. Now what I'd like to point out is that when you sample a chunk of data like this, so say these 9 characters out of the training set, this
block size is supposed to be the context window, right? Okay.
Actually has multiple examples packed into it. And that's because all of these characters follow each other. And so what this thing is going to say when we plug it into a transformer is we're going to actually simultaneously train it to make prediction at every one of these positions. Now, in a chunk of 9 characters, there's actually 8 individual examples packed in there. So there's the example that when in the context of 18, 47 likely comes next. In the context of 18 and 47, 56 comes next. In the context of 18, 47, 56, 57 can come next, and so on. So that's the 8 individual examples. Let me actually spell it out with code. So here's a chunk of code to illustrate. X are the inputs to the transformer. It will just be the first block size characters. Y will be the next block size characters, so it's offset by 1. And that's because Y are the targets for each position in the input. And then here I'm iterating over all the block size of 8. And the context is always all the characters in X up to T and including T. And the target is always the T character, but in the targets array Y. So let me just run this.
Yeah, I need you to repeat that because my brain gets foggy sometimes. Okay.
And so on. So that's the 8 individual examples. Let me actually spell it out with code. So here's a chunk of code to illustrate. X are the inputs to the transformer. It will just be the first block size characters. Y will be the next block size characters, so it's offset by 1. And that's because Y are the targets for each position in the input. And then here I'm iterating over all the block size of 8. And the context is always all the characters in X up to T and including T. And the target is always the T character, but in the targets array Y. So let me just run this. And basically it spells out what I said in words. These are the 8 examples hidden in a chunk of 9 characters that we sampled from the training set. I want to mention one more thing. We train on all the 8 examples here with context between 1 all the way up to context of block size. And we train on that not just for computational reasons because we happen to have the sequence already or something like that. It's not just done for efficiency. It's also done to make the transformer network be used to seeing contexts all the way from as little as 1 all the way to block size. And we'd like the transformer to be used to seeing everything in between. And that's going to be useful later during inference, because while we're sampling, we can start a sampling generation with as little as 1 character of context. And the transformer knows how to predict next character with all the way up to just context of 1. And so then it can predict everything up to block size. And after block size, we have to start truncating, because the transformer will never receive more than block size inputs when it's predicting the next character.
Right.
Okay, so we've looked at the time dimension of the tensors that are going to be feeding into the transformer. There's one more dimension to care about, and that is the batch dimension. And so as we're sampling these chunks of text, we're going to be actually, every time we're going to feed them into a transformer, we're going to have mini batches of multiple chunks of text that are all like stacked up in a single tensor. And that's just done for efficiency, just so that we can keep the GPUs busy, because they are very good at parallel processing of data. And so we just want to process multiple chunks all at the same time. But those chunks are processed completely independently, they don't talk to each other, and so on. So let me basically just generalize this and introduce a batch dimension. Here's a chunk of code. So I'm just run it, and then I'm going to explain what it does. So here, because we're going to start sampling random locations in the dataset to pull chunks from, I am setting the seed so that in the random number generator, so that the numbers I see here are going to be the same numbers you see later if you try to reproduce this. Now the batch size here is how many independent sequences we are processing every forward-backward pass of the transformer. The block size, as I explained, is the maximum context length to make those predictions. So let's say batch size 4, block size 8, and then here's how we get batch for any arbitrary split. If the split is a training split, then we're going to look at train data, otherwise eval data. That gets us the data array. And then when I generate random positions to grab a chunk out of, I actually generate batch size number of random offsets. So because this is 4, IX is going to be 4 numbers that are randomly generated between 0 and len of data minus block size. So it's just random offsets into the training set.
Why?
And then X's, as I explained, are the first block size characters starting at I. The Y's are the offset by 1 of that, so just add plus 1. And then we're going to get those chunks for every one of integers I in IX, and use a torch.stack to take all those one-dimensional tensors, as we saw here, and we're going to stack them up as rows. And so they all become a row in a 4x8 tensor. So here's where I'm printing them. When I sample a batch XB and YB, the inputs to the transformer now are, the input X is the 4x8 tensor, 4 rows of 8 columns, and each one of these is a chunk of the training set.
Right.
And then the targets here are in the associated array Y, and they will come in to the transformer all the way at the end to create the loss function. So they will give us the correct answer for every single position inside X. And then these are the 4 independent rows. So spelled out, as we did before, this 4x8 array contains a total of 32 examples, and they're completely independent as far as the transformer is concerned. So when the input is 24, the target is 43, or rather 43 here in the Y array. When the input is 24, 43, the target is 58. When the input is 24, 43, 58, the target is 5, etc. Or like when it is a 52, 58, 1, the target is 58. Right, so you can sort of see this spelled out. These are the 32 independent examples packed in to a single batch of the input X, and then the desired targets are in Y. And so now this integer tensor of X is going to feed into the transformer, and that transformer is going to simultaneously process all these examples and then look up the correct integers to predict in every one of these positions in the tensor Y. Okay, so now that we have our batch of input that we'd like to feed into a transformer, let's start basically feeding this into neural networks. Now, we're going to start off with the simplest possible neural network, which in the case of language modeling, in my opinion, is the bigram language model. And we've covered the bigram language model in my Make More series in a lot of depth. And so here I'm going to sort of go faster, and let's just implement the PyTorch module directly that implements the bigram language model. So I'm importing the PyTorch NN module for reproducibility. And then here I'm constructing a bigram language model, which is a subclass of NN module. And then I'm calling it, and I'm passing it the inputs and the targets. And I'm just printing. Now, when the inputs and targets come here, you see that I'm just taking the index, the inputs X here, which I renamed to IDX, and I'm just passing them into this token embedding table. So what's going on here is that
messages that I did not notice.
We are creating a token embedding table.
Hi. Would I share my intended overall course plan and outline how to so this is not my video. I'm not the guy talking, I'm the lady talking. MD Yazid and Epsilon? That's a cool name. Oh, hi. Okay, I know you. I'm okay, so here's the thing. I finished the title, because right now the title is lesson 12, the title of this live you're watching. I finished this like 20 minutes ago, and I didn't want to end the stream, so I just went to this build nano GPT. I can share the video, I'm sure I can, so I will right here as a message. What did I do? Guess I didn't copy it. So that you can also go here. I can even share the collab because, like, Andrei Karpathy is a researcher, famous researcher. He knows what he's doing, and all of his stuff is here. The GitHub repo, the collab. So yes. Yes. He is someone to be trusted. The video is 1 year old, which I think is fine because he said he's trying to recreate the capabilities of GPT-2, which he has done. Isn't that pretty cool? Yeah. Sorry, I was like too immersed in the video to notice that there was some chat. Of course. No, he's a really famous researcher. Like if you just Google his name, there we go. Google it for me. I'm sure you guys know him because you are also aware of the. Where was he working? I know. Okay, so he was at Tesla and then co-founded and worked at OpenAI. So yeah, he knows what he's doing. You might think. Oh, I think I know him because of Dr. Fei-Fei Li. He was Dr. Fei-Fei Li's student. That makes sense. So he is, that's the thing that's surprising is that during the vision, okay, now it's no longer surprising because I was about to say Dr. Fei-Fei Li is famous for vision, but he's connecting image and NLP, which is pretty cool. Um, what's so funny? What's with the ha ha ha? um, yeah. Okay. Yeah. So I will probably be here for like another 10 to 15 minutes because this video is pretty long. I don't know if I will finish it on stream, but I'll probably finish it off stream because it's like I sort of understand what he's doing, which is surprising for me.
And it is of size.
I'm just saying that I don't always understand AI and ML related things because I'm human.
Vocab size by vocab size. And we're using an n-dot embedding, which is a very thin wrapper around basically a tensor of shape, vocab size by vocab size. And what's happening here is that when we pass IDX here, every single integer in our input is going to refer to this embedding table and is going to block out a row of that embedding table corresponding to its index. So 24 here will go to the embedding table and will pluck out the 24th row. And then 43 will go here and pluck out the 43rd row, etc. And then PyTorch is going
Yeah. Yeah. He knows what he's doing.
to arrange all of this into a batch by time by channel tensor. In this case, batch is 4, time is 8, and C, which is the channels, is vocab size for 65. And so we're just going to pluck out all those rows, arrange them in a B by T by C, and now we're going to interpret this as the logits, which are basically the scores for the next character in the sequence. And so what's happening here is we are predicting what comes next based on just the individual identity of a single token. And you can do that because, I mean, currently the tokens are not talking to each other, and they're not seeing any context except for they're just seeing themselves. So I'm a token number 5, and then I can actually make pretty decent predictions about what comes next just by knowing that I'm token 5, because some characters follow other characters in typical scenarios. So we saw a lot of this in a lot more depth in the Make More series, and here if I just run this, then we currently get the predictions, the scores, the logits, for every one of the 4x8 positions. Now that we've made predictions about what comes next, we'd like to evaluate the loss function. And so in Make More series, we saw that a good way to measure a loss, or like a quality of the predictions, is to use the negative log likelihood loss, which is also implemented in PyTorch under the name cross entropy. So what we'd like to do here is loss is the cross entropy on the predictions and the targets. And so this measures the quality of the logits with respect to the targets. In other words, we have the identity of the next character, so how well are we predicting the next character based on the logits? And intuitively, the correct dimension of logits, depending on whatever the target is, should have a very high number, and all the other dimensions should be a very low number, right? Now, the issue is that this won't actually, this is what we want. We want to basically output the logits and the loss. This is what we want, but unfortunately, this won't actually run.
Because?
But intuitively, we want to measure this. Now, when we go to the PyTorch cross-entropy documentation here, we're trying to call the cross-entropy in its functional form, so that means we don't have to create like a module for it. But here when we go to the documentation, you have to look into the details of how PyTorch expects these inputs. And basically the issue here is PyTorch expects, if you have multi-dimensional input, which we do, because we have a B by T by C tensor, then it actually really wants the channels to be the second dimension here. So if you, so basically it wants a B by C by T instead of a B by T by C. And so it's just the details of how PyTorch treats these kinds of inputs. And so we don't actually want to deal with that. So what we're going to do instead is we need to basically reshape our logits. So here's what I like to do. I like to take, basically give names to the dimensions. So logits.shape is B by T by C, and unpack those numbers. And then let's say that logits equals logits.view, and we want it to be a B times T by C. So just a 2-dimensional array, right? So we're going to take all of these positions here, and we're going to stretch them out in a 1-dimensional sequence and preserve the channel dimension as the second dimension. So we're just kind of like stretching out the array so it's 2-dimensional, and in that case it's going to better conform to what PyTorch sort of expects in its dimensions. Now we have to do the same to targets, because currently targets are of shape B by T, and we want it to be just B times T, so 1-dimensional. Now alternatively you could always still just do -1, because PyTorch will guess what this should be if you want to lay it out, but let me just be explicit and say U times T. Once we've reshaped this, it will match the cross-entropy case, and then we should be able to evaluate our loss. Okay, so with that right now, and we can do loss. And so currently we see that the loss is 4.87. Now, because we have 65 possible vocabulary elements, we can actually guess at what the loss should be. And in particular, we
How?
covered negative log likelihood in a lot of detail. We are expecting log, or ln, of 1 over 65 and negative of that. So we're expecting the loss to be about 4.17, but we're getting 4.87. And so that's telling us that the initial predictions are not super
Hello.
diffuse.
Check. Hi. It's going well. It's going well. I finished the course that is the title of this stream, and I'm just like trying to learn around. Yes, if I can answer, ask away, but no promises. Go ahead.
They've got a little bit of entropy, and so we're guessing wrong. Yes, but actually we are able to evaluate the loss. Okay, so now that we can evaluate the quality of the model on some data, we'd like to also be able to generate from the model. So let's do the generation. Now I'm going to go again a little bit faster here because I covered all of this already in previous videos. So here's a generate function for the model. So we take take the same kind of input, idx here, and basically this is the current context of some characters in some batch. So it's also b by.
I'd like to create a bot that can take two chats, text as input, and generate an answer. Huh. Text to speech. Wait, okay. Live Twitch chats? Okay. As input. I think that's possible. Generate. So you wanted to answer the people? You want a bot that can answer people? Christian Dispatcher, help me create a model that is. Ooh. That's. I'm sorry to say I'm not as knowledgeable in PyTorch to tell you, but what you're saying, like what you're asking, seems doable. Does anyone does anyone else from the chat know anything about this? Because it feels possible. You could probably. Do you want to make something or use something that's already existing? Because I think it would be easier for you to use something that's already existing to do the answering part. Oh, what would someone use PyTorch for? That's a good question because from my understanding, and my understanding is very limited, so do not take okay, so you want to probably like fine tune an existing model, right? From my understanding, I think, again, my understanding is very limited. Do not take it with a grain of salt. I think PyTorch is mostly used if you want to do the nitty gritty of the things, like very detailed math for ML. So even if you, like, even take me as an example of saying I don't know a lot, I'd still recommend using PyTorch because then if you want to make a lot of changes, you could probably do that. So yeah, that's a really cool idea. Are you going to try and make it on stream? Because that would be really cool if you did. I think you can probably find something on GitHub and try to fine tune it and see if they are using PyTorch or not, right? What do you think? Web dev, okay. I mean, I am still like trying to not drown in this level of knowledge, so I think learning while making things is probably better, better strategy than just learning without making anything out of it, which seems to be my current strategy. I sort of answered, but not really, because like I said, I don't have a lot of experience / I haven't made things, which is, not good. But like I've just used Python, because I don't have, but like just seeing him use a lot of PyTorch, Andre Karpathy, um, like I know PyTorch is being used by a lot of people because of using it for the nitty gritty math part. Like it is fast. It has a lot of functions that do the things that need to be done if you know what you're doing. I normally don't always, but you can probably figure it out. It's fine. So your project is a really cool idea, and like I don't know, I could like think about it and say where would I start, but I think you have a better idea of what you want to do. Yeah. Yeah. Me. Okay. Yes, I do have a goal. And I guess just I want to understand what's happening in the world, in the learning for fun part, but for the goal, um, my current goal is, um, okay, so to be able to fine tune a model for the things that are related to my language. So I need to understand, like just now watching this video, it got me like it gave me the idea of okay, this video is with Shakespeare's, like he's using Shakespeare's I don't know, like every Shakespeare text as training data. I could use another training data that's not in English and see what happens, and if it makes sense, because it probably should, because of the encoder decoder part. And yeah, like my goal is making what's already out there for English language and using it for my language, which is not the English language, and it's using a different um, letter based system thing. And my current focus is actually audio, but I want to have a better base before I jump to audio. Um, yeah, and I think my next to do is going on Hugging Face, and like because these are very practical, and yeah, like this one is, I think, very like, yeah, I think this one is um like starting from zero, giving you a lot of information, giving you assignments. This is also something that is like calling me in a way. But I don't want to be in tutorial hell. I also think these are very useful, and this is like putting you right in the middle, whilst this is giving you um, information. Of course, it's free. Yes, you don't know Hugging Face has courses. Wait, let me go to the main here. huggingface.co/learn. Here you go. God, what's wrong with this? Paste. There you go. It has NLP course, which is like just NLP, deep reinforcement learning, computer vision, audio course. I don't know what's this. Open source AI cookbook, ML for games, diffusion, ML for 3D, following the pattern from. Oh, that's so cool! I love Free Code Camp. Um, yeah, of course. Um, yeah. So when I was first, like, I don't know, a month ago, I learned about Hugging Face courses. I think they had up until here, and they added 3 more courses very recently. So things are being updated, which is pretty cool. Yeah. So, where was I? Yes. I think. Let me see if I can finish this part because my time is nearing its end, and I am enjoying talking to the cool people in chat. For your case, which course should be taken? Okay, so it's cool that you're taking the PyTorch course, because like if I know nothing about PyTorch, how do I know to use it, right? Um, and your idea is fine-tuning an existing model. I don't want to be biased, but because I am planning to take this course, I think you see that it says this part, it says fine-tuning a pre-trained model. So I think that would be very useful for you. Or even if you don't want to take a course, you could probably just Google fine-tune um, a model for chat responses. I'm sure someone's made something on it, because there are, like, the one that I was really interested was fine tuning Whisper, which is ASR model that is created by, shoot, what I no 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 no, no sorry, which is created by OpenAI. But my current issue is that I think it needs higher resources than just using Colab. So anyway, I'm just saying, like, you could probably find something. Um, okay, okay, yeah, I think so. It's easier. I think if you start there, you can probably jump to making. Uh, you're welcome, but I also don't want you to, like, follow everything. I'm sure you won't, because I know you already know what you're doing. Yeah. In case my advice is bad, I'm sorry, but I think it's okay. My advice. Um, I have become a bit more comfortable with giving advice about what to learn, because um, I have younger people around me that ask me those things. So yeah. Mm, Sometimes I have to remind myself that I have the credentials and experience to give people advice, because I have a hard time doing that. um, Thank you. And honestly, good luck. Uh, I think definitely you'll figure it out, but I think even, like, I don't know if you had the chance to watch this video, but from, like, like a normal thing would be reading out your data and then processing it and then giving it to the model. I think from the processing part, you'd probably need some PyTorch. And then, like, even this guy here is creating it himself, not finding an existing model, but I think, yeah, like I said, I don't have enough information, even though I do want to have information. Um, I guess just seeing other people using it in their code, you're like, oh, I've seen this. Um, and I guess it would be useful. Um, yeah. So update me make any, if you make anything. Yes. Get the input, the processing part, then spit out the output. So I guess after processing, you still need to train a model so that it can spit out output, but that should be the some basic idea of your roadmap. Um, if you want me to somehow help you with this, do let me know. Like, you can shoot me a message on Twitter. I can try. Okay? What do you think? I hope so. I hope so. No problem. Just because I haven't, uh, I guess I have worked on some stuff, but they are not close to what you're saying. That's why, ah, okay, no problem. um, you can send me an email. Oh, I do have Discord. Okay. To be honest, I don't know how to connect on Discord. I'm old. But if you want, I can try. I think YouTube doesn't allow talking to people in a way. There's no DMing. Um, Let me see if I have Discord. No, no. It's not about having to. It's like I'm being greedy to say, he's making. I mean, he or she. I'm sorry. I don't know. You're making something interesting, and I want to be a part of it. It's that part. But if you're not comfortable with that, I don't mind. um, Thank you. Mm, Pup, pup. Yes. Okay. So I will. Okay.
by t, and the job of generate is to basically take this b by t and extend it to be b by t plus 1, plus 2, plus 3, and so it's just basically, it continues the generation in all the batch dimensions in the time dimension. So that's its job, and it will do that for max new tokens. So you can see here on the bottom, there's going to be some stuff here, but on the bottom, whatever is predicted is concatenated on top of the previous IDX along the first dimension, which is the time dimension, to create a b by t plus.
Oh no. Oh god, that scared me. That
Chicken
was.
just followed. CL welcomes you.
Thank you. That really, really scared me. Um, Thank you so much for the follow. You didn't have to. But thank you for doing so. I was actually just on Discord. Sorry, I think my voice is low. That's why. Oh shoot, what did I do? That's why I always yeah, when another sound happens, yeah. Um, it's louder, but I don't know why my voice is very low. I guess I need to scream when talking. Um, yeah, I was just on what is happening? There we go. I was on Discord just to see, and I saw that I had a friend request from someone that like is a friend, and it was from a year ago, and I was like, what? And then that sound happened, and that scared me. Um, yeah, okay. Uh, okay. Huh. Anyway, I am very distracted right now. Let me see if I can finish this part. I don't know how long is left. 5 more minutes.
Plus 1. So that becomes a new IDX. So the job of generate is to take a b by t and make it a b by t plus 1, plus 2, plus 3, as many as we want max new tokens. So this is the generation from the model. Now inside the generation, what are we doing? We're taking the current indices, we're getting the predictions. So we get, those are in the logits. And then the loss here is going to be ignored because we're not using that, and we have no targets that are sort of ground truth targets that we're going to be comparing with.
Okay.
Then once we get the logits, we are only focusing on the last step. So instead of a b by t by c, we're going to pluck out the -1, the last element in the time dimension, because those are the predictions for what comes next. So that gives us the logits, which we then convert to probabilities via softmax. And then we use torch.multinomial to sample from those probabilities, and we ask PyTorch to give us one sample. And so IDX next will become a b by 1, because in each one of the batch dimensions, we're going to have a single prediction for what comes next. So this num samples equals 1 will make this be a 1. And then we're going to take those integers that come from the sampling process, according to the probability distribution given here, and those integers just get concatenated on top of the current sort of like running stream of integers. And this gives us a p by t plus 1. And then we can return that. Now, one thing here is, you see how I'm calling self of IDX, which will end up going to the forward function. I'm not providing any targets. So currently this would give an error because targets is sort of like not given. So targets has to be optional. So targets is none by default. And then if targets is none, then there's no loss to create. So it's just loss is none. But else, all of this happens and we can create a loss. So this will make it so if we have the targets, we provide them and get a loss. If we have no targets, we'll just get the logits. So this here will generate from the model. And let's take that for a ride now. Oops. So I have another code chunk here, which will generate from the model. And okay, this is kind of crazy. So maybe let me let me break this down. So these are the IDX, right? I'm creating a batch will be just 1. Time will be just 1. So I'm creating a little 1 by 1 tensor, and it's holding a 0. And the data type is integer. So 0 is going to be how we kick off the generation. And remember that 0 is the element standing for a new line character. So it's kind of like a reasonable thing to feed in as the very first character in a sequence to be the new line. So it's going to be IDX, which we're going to feed in here. Then we're going to ask for 100 tokens, and then end up generate.
Yeah, I'm lost.
Now, because generate works on the level of batches, we then have to index into the 0th row to basically unblock the single batch dimension that exists, and then that gives us a time steps, just a one-dimensional array of all the indices, which we will convert to simple Python list from PyTorch tensor, so that can feed into our decode function and convert those integers into text.
I'll definitely rewatch this part because I sort of understood but then I got lost. I'll rewatch it on my own later. I just want to see if he runs it.
So let me bring this back, and we're generating 100 tokens. Let's run. And here's the generation that we achieved. So obviously it's garbage, and the reason it's garbage is because this is a totally random model. So next time we're going to want to train this model. Now, one more thing I wanted to point out here is this function is written to be general, but it's kind of like ridiculous right now because we're feeding in all this, we're building out this context, and we're concatenating it all, and we're always feeding it all into the model. But that's kind of ridiculous because this is just a simple bigram model. So to make, for example, this prediction about k, we only needed this w. But actually what we fed into the model is we fed the entire sequence. And then we only looked at the very last piece and predicted k. So the only reason I'm writing it in this way is because right now this is a bigram model, but I'd like to keep this function fixed, and I'd like it to work later when our characters actually basically look further in the history. And so right now the history is not used, so this looks silly, but eventually the history will be used, and so that's why we want to do it this way. So just a quick comment on that. So
I'm curious. Okay, this is the training part. I'll put this video in the chat in case anyone wants to watch it. I already did it, but I'll do it again if you didn't see it. Yeah, I'm curious if the window of the 8, oh my god, what's wrong with me? The window of the 8 characters has anything to do with the history part, because we already had a window. Anywho, if all goes well, I'll start tomorrow, probably with this hugging face. We'll see, because like if I do this one and it's, I don't know, and it takes like half an hour, I doubt it. I can do the other. We'll see. I can divide my time between these two, because for some reason I feel like these two are my destiny. Starting is always easy, but wait, why is it so slow? Starting is easy, but continuing and finishing the project is not the easiest. What's with the character being so slow? Sorry about that. I have no internet issues, but I don't know why. Testing. Anyway. Okay. Oh wow. Usama Mah Mah Mahjoub. Hello, hello. Thank you for passing by. I'm technically about to end the stream, so thank you for catching it last minute. Thank you for all of the nice people that chatted with me. Thank you for asking me questions, and I hope whatever I answered is somewhat useful. And I hope we can learn together, because I know I have to remind myself I have a master's degree. I have like 8-9 years of work experience, but that doesn't mean I know everything. Things are growing. At least I know. I think I know how to learn, which is a good skill to have. Just let's not fall into tutorial hell. Thank you. Do that. Huh? Snake game? You're working on that? That's cool. That's pretty cool. That is very, very cool. Game is made. Yes, amazing. Okay, that's very, very cool. Wish you success. And if you have the chance, I do think you should stream the learning and the learning and the working on the stuff part. I think streaming it would be pretty cool. So I hope you do that, and when you do, I'd like to see it. Okay. All right. Thanks again for passing by. If all goes well, I'll see you tomorrow. Okay, I'm gonna end the stream in 5. If you have anything to say, declare it now or forever be quiet. 4, 3, 2, 1. Thank you so much. Really appreciate it. Goodbye.